is the control?
Oh, no worries. I did it. You can
Oh,
just...
you took over the control anyway. Okay, perfect. Okay.
Hi, everyone. I guess people are still joining. Let's wait for like 10 seconds more. Hi, hi. How are you guys? Hi, everyone. And hello to all the audience on YouTube as well. I hope you guys are excited for today's session. So as you know, at Insaid, we try to come up with these speaker sessions so that we can give you a real life representation of the field that you're trying to get into, right? But today we have a very special guest with us to share to share her story and the things that she has came up for so far. And why do you ask that this special guest is so special for this occasion? Well, there is a very specific reason behind that, and that is all of the people that are coming to Inset to actually go through their journey of transitioning into a data science role. That word transition was kind of a myth for us, right? Because all the speakers that we have seen so far has been working as a data scientist from the get-go, right? And that is why Preeti Ravindra is very special for us because she has actually portrayed how you can utilize the information that you get in from data in any of the field that you want to use it in. Initially, she was not from a data domain. She will tell you from which domain she's actually coming from, but I will just like to add that she actually used the data and the information that you can gain from it to access her own skill set in a way that she can progress in the domain that she's working. And that is a very good example of how you can do it too. So let's see what she has to say for us. Preeti, over to you.
Thank you, Yash, for the intro. So will I be starting my video because it says unable to start my video because the host is stupid?
Oh, I guess you can. Let me just check it once more, right? Try it once more. It might be a technical difficulty. Yeah,
Yes,
sure.
now I can.
Can see you now.
Okay, great. Perfect. Awesome. All right. Let me just quickly share my screen and then we can take it from there. All right. So firstly, thanks, Yash, for the intro. It's really exciting looking at the audience turnout here, both on Zoom and a couple of folks on YouTube as well. So this is a great number for the Saturday evening talk. I feel very fortunate and appreciated. And in the spirit of the weekend, I'd like to keep this as informal and interactive as possible. To whatever extent we can make that happen in a webinar context. So just a customary legal disclaimer before I start is that I'm doing this on my own personal time, and anything that I share here does not represent the opinion of any of my past employers. So the good part about that is that there is no marketing material. It's everything's going to be like something that I have created for us. And I also know that this is folks who are part of Insaid, who are also public, available to general public. So I'd like to just understand who my audience is and learn a bit about you. My initial impression based on Yash's intro was that most of you are looking to get your feet out the door and land your first role as a data scientist or in any data role for that matter. So Can we do a quick raise of hands? You can do this virtually either on Zoom and, or like type on YouTube chat saying where it is you are in your journey. Like, have you taken any online course? If yes, please raise your hand. Okay, I see about a lot of participants slowly raising their hands on Zoom.
Yeah, the number
So
is
most
going up. Yeah.
Okay, great. So it looks like a lot of people have already taken some form of online course that is data related. That's fantastic to know. How many people here are early practitioners? You've like just started in your first data role. It could be any kind of data role. It could be data scientist, business intelligence analyst, data engineer, machine learning engineer. Okay, I see a couple of hands going up. I'm not sure if these are still the raised hands for the previous question, but I see about 8 to 9. So it looks like most of the people here are looking to break into the field. Um, so that's the right kind of audience for me. I also see some chats here saying a lot of people here are students also, so that's fantastic. That's good to know. Some folks are transitioning from QA into manufacturing. Very nice. That's pretty cool. All right. So the agenda for today, I'll just like quickly go over this. I talk about my journey so far, what it has been in my career. I'll talk about some of the problems that I have worked on, the use cases specifically, and provide you a framework as to how to approach any given problem. And then we can do an interactive session where I'll actually get some inputs from you to figure out what kind of problems you're looking at, how you can actually find a problem within your space that you're currently working in, and then transition into a data science role. We'll cover the different flavors of data roles, such as data analyst, data engineer, data scientist, machine learning engineer. And then towards the end, I'll talk about how you can start today, like what you can do right now today, and iterate on some of the benefits. And then, of course, there'll be like a feedback survey because I'd love to get your inputs. I'll give sufficient pauses during this chat, during this video call, so that we can so that I can take answer questions and also do my best to answer a lot of your questions. So, my journey so far. In the past, I was a security researcher. My domain was information security. And I think that's what Yash was alluding to during the intro as to what my previous background is. Um, one of my goals or one of my mantras in life is you can call me whatever you want. You can call me a security researcher. You can call me a data scientist. You can call me a data engineer. Um, you can give me any title because as you can see here, I've held a lot of different titles in my journey so far. Regardless of what my title was, I've always used data to solve business problems. I've been fortunate to be the founding member of a lot of product teams. That meant that I've interfaced with product management, with software development teams. I have been in a software development team and a security team myself, user experience, design researchers. These are fairly common interactions that you typically have as a data professional once you're in the industry. And I've delivered analytics solutions. Uh, we can talk about basic analytic solutions. I've also delivered actual machine learning algorithms and AI solutions for the enterprise security teams, as well as for security vendors. I've seen quite a few ways in which data can be leveraged for business outcomes and broadly work in the um, data space. So quickly, as a security researcher, my job was to find the biggest hack, or like who are our attackers, how are they breaching environments, and then that transitioned into what's the best way to catch these attackers. So some of the existing technologies have some limitations. Can we cover up those limitations? Can we make up for those limitations with some of the newer technologies? And that's how I got into doing machine learning. So there was one example where I wanted to determine the different kinds of exploits that were happening. And the answer for that was regular computer science or software was not doing a great job, but there were certain natural language processing techniques that were actually beneficial to help achieve the end goal that we wanted. So I've ideated, developed, and integrated about 3 to 4 different AI models in different products in both the tech and the finance space. Currently, what I'm interested in doing is, since I've been fortunate to have like these wide variety of roles, like researcher role, engineering role, data scientist role, I've seen what kind of teams work, how teams should come together. So in my current role, I'm really passionate about helping businesses get value out of their data and have successful AI and machine learning solutions. I don't want to scare anyone before you even get started, but typically the industry success rate for a successful data science project is at about 80%. And especially in my domain, which is the cybersecurity domain, it's more than that. The failure rate is about 80%, and in cybersecurity, it's more than that. So it's a difficult challenge, and since because of these experiences, I've been fortunate to build out the teams and help people both use AI for security as well as securely adopt AI. I still have a long way to go in terms of my learning as well. I'll just quickly give some of the problems that I have worked on in the security space, and I'll provide some context. I understand most of you are still in the early stages, so I'll try to be as verbose as possible and explain the basic building blocks and what it looks like to solve these problems in the industry. Um, Without going too much into the security aspects, I'll just touch upon this thing. Like, domain knowledge is important. And for me, that has been a huge helping factor to transition or to leverage my data skills. The domain knowledge has been super important. So typical use cases, or the most prevalent ways in which AI solutions have been used and adopted in this industry are mostly around 3 themes. Like the first themes is, okay, we want to detect the latest threats. Like, how do you detect some malicious activity that's happening? Most of the times, these are modeled as outlier detection problems or anomaly detection problems. I think a lot of you taking the online courses or being part of Insaid's classes would have some exposure to what it means. So typically, we're trying to look for something that is interesting and something that spikes the attention of somebody who's looking at all the security events. So that is the typical threat detection use case. And then there are certain use cases where we're trying to augment the human capabilities. So instead of telling that, okay, we will let AI do everything for you, we will let machine learning do everything for you, it's not there yet. We want the humans to work hand in hand with the machine learning outputs. So we use machine learning to help improve the tooling for humans. So for example, a classic example in the security domain is the alert fatigue problem. What this means is somebody who is in an operational role keeps looking at millions of alerts every day saying something is wrong, or this is a potential data breach, something is not a potential data breach. How do they decide? In order to decide, they have to go through so many steps, such as investigating different data sources. They also have to understand the context and determine whether something is truly worthy of investigating further or not worthy of investigating further. And most humans have only 5 minutes to do this. That's a huge task, and that's not necessarily the strength of a human. But the strength of a computer is the speed at which it can process data. And if we can augment that with some intelligence, by intelligence, I mean anything like simple descriptive analytics or simple machine learning models, that itself is a huge boost because the human can get a lot of work done within those 5 minutes. So these are what I would call as, decision support or operational efficiency, because you're helping the human make a decision. This is one classic use case of how AI has been adopted in the security industry. There are some other places, like other things like workflow improvements, but not really that important. I'd like to move on and talk about the key challenges that we face in my industry. So the first one is lack of labeled data. How many of you here are familiar with supervised learning versus unsupervised learning? Just a quick raise of hands over Zoom, please.
Guys,
Have
I
you
want
heard
more
of these
hands
terms?
going up. We are students of ours, so please. Okay,
Nice.
numbers
I
going
see
up.
about 25, 26. Okay, that's great. So a lot of people here know what supervised learning is and unsupervised learning is. So in unsupervised learning, just to keep it simple, um, it's like it's like the child doing the shape sorting activity. Oh, this has four edges, but everything is square, so this must be like or everything is perpendicular to each other, so this must be a square. Or this has like funky edges, so this must be a star. We don't actually explicitly teach what is a square or star, but they just sort of shape sort it. So that's unsupervised learning analogy for the uninitiated. And for supervised learning, it's like a teacher teaching, oh, this is A, this is B, this is a dog, this is a cat. These are the popular examples. So lack of label data is a huge challenge in the domain that I work in. And class imbalance, again, is a problem where you get labels of only one kind and not the other kind. So typically classification problems are things like, is it a dog or a cat? Or is it a cat or not a cat? Hot dog, not a hot dog. So these are typical class imbalance problems. And in security, it's like malicious or not, threat or not. And class imbalance happens when you see labels of only one kind. And this is a problem because you can't teach the model about what it looks like when it's a different class or when it's a very underrepresented class. Of course, there are techniques to mitigate this, but this is one of the key challenges. And the other challenge is unstructured information. And finally, one challenge that's super unique to the domain that I work in is malicious intent, where we actually have adversaries trying to intentionally misuse any technology we develop. It could be software, it could be machine learning models. This is something that is kind of unique here because everybody's trying to bypass the models and actively trying to evade our defenses. So as a security researcher, what was one of my biggest job? My biggest job, or this is what my morning looked like, right? My morning looked like reading all those articles, finding out the latest happenings. So on the right, you can see, I've been reading like dark reading, hacking articles, malware don't need coffee, so many things. This is just like one bookmark, and look at the amount of things that I had to read. And then lastly, there's like so much unstructured information, right? There are ways in which this unstructured information is useful, but this is not a typical problem for software, where you write regular expressions. In order to write regular expressions, you should know what already exists. So for that, I'll have to develop things that I already know. But here, there are some things that I don't know. And how do I want to use this? So this is a classic use case for natural language processing. If you've heard things like, okay, I'm using the term natural language processing a lot, so let me take a break here, pause here, and see how many people here are familiar with natural language processing. Okay, so natural language processing is nothing but understanding the languages that we as humans speak. This is not in the form of a table. This is not in the form of any structure relationship or there's no formality to this language. It's just about what we speak. And making a computer understand this is essentially natural language processing. So this is a huge benefit. These are ways in which if you could simply do things like sentiment analysis or extracting the right kind of entities, extracting the right kind of relationships. This is super useful because now I can build a big security knowledge corpus for us. So this was one of the ways in which we can actually leverage data science. And this was a huge challenge that we had before. One other thing that I'd like to add here is with this, it's not just about knowing natural language processing, it's also about understanding the domain itself, right? I have to understand the domain to say whether some information that is being extracted is valuable or not. So that is another key aspect that played into me transitioning from this researcher role into this applied researcher role, where I was looking at, oh, does this make sense for my domain? Does it not make sense for my domain? So this other problem, the lack of labeled data and class imbalance. So here's a on the right side, you can see like it's just a Jupyter Notebook snapshot that I've taken. It's a training data set, and I'm looking at the labels and see how different the labels are. Like the number of clean or normal labels that we're seeing is so much more than the number of malware labels that we're seeing. So the clean sample files are in the order of hundreds of thousands, and the malware sample files are in the orders of like 10,000. So this is another problem that we face. And then on the left side, I have this snippet of something that's malicious, but nobody tells me that it's malicious. Like this is what a typical machine learning classifier that we build in security would say, oh, this is malicious or this is not malicious, but I have no label to this. So we have a lot of these kinds of problems here. Lack of labeled data, class imbalance. All of these are very unique problems, but these unique problems to AI and machine learning can still be mitigated because we have a lot of new tools available to us, such as there are some libraries like the imbalanced learning libraries that will help us do sampling the right way in order to, identify this. Then there are advances such as self-supervision, where you actually don't even need a lot of labels. But for that, you need to have a lot of data. And then once you have a lot of data, self-supervision can help teach your own models. And lastly, this is an example of malicious intent. So researchers actually were trying to break into a model that was actually deployed on an antivirus solution. This was done a few years ago. So this is publicly disclosed in the domain, and this has been patched. So that's why I'm talking about it here. At a very high level, the goal of an antivirus solution is to say whether some file is malicious or not. And they used a model to tell whether some file is malicious or not. So here you can see the different types of malwares, and you kind of identify each file through this malicious, through this SHA hash. You identify it through the hash. So initially, the classifier was actually telling that all of this was malicious. So a negative score indicated that the sample was malicious. But what our adversaries did in order to fool this model was they realized that there was a secondary model that went along with the primary model. And the job of the secondary model was to correct for the enormous amount of gaming software that were classified as malicious. So what the adversaries did was they extracted some strings that was typical of that gaming software and attached that string to the malware sample. And immediately the machine learning classifier went from a negative score to an exact opposite positive score. So this was an example of how you can attack machine learning models. And this is a huge problem for me as a data scientist trying to build this, because I need to think about different ways in which people can attack my models. I need to think about how I can build the best software, the best and the most robust algorithms that will still stand the test of time. And this is a very active area of research. But I just thought it would be interesting to share it with the up and coming data scientists so that you're all inspired to become better data scientists and build better models for all of us. At this point, I'll just talk quickly about some of the frameworks, right? Like if you're starting in a new role, what is it that you really need to do? I just spoke about the challenges and some different kinds of problems that I solved. But what you didn't see me talking about was how I approached this. And this is something that will set you apart when you are moving from a student role or somebody who is learning to an early career professional in a data role. So the most important thing that I would say for you is having a business understanding. And this is not just if you're an analyst or a scientist, even if you're a software developer, even if you're a machine learning engineer, having that business understanding is extremely critical. An example for me, I got vague business problems in the beginning saying, my product managers would come to me and the problem that they would say is, Preeti, our security professionals need more context. Please provide context. Or Preeti, our security professionals are swimming in false positives. Or by false positives, I mean things that are um, identify as malware, but not necessarily malware. So these are high-level business problems, right? What does this actually mean? What is the definition of a false positive? What does it mean to provide context? All of this information is extremely critical for me to help translate that business problem into a technical problem. And I think that is a very key concept that a lot of early career professionals don't do. And that is something that I would encourage everybody to develop right away. You get vague requirements, clarify those requirements, and translate those business problems into the appropriate technical problems. So in my case, what it looked like was help reduce false positives. What does it mean to help reduce false positives? What is the outcome? So the outcome was I was supposed to reduce the queue of billions of events that the analyst sees in a given day. So instead of 1 million or 1 billion events, even if I reduced it by 50%, that would make it like 500,000 and much more manageable. And the business outcome would be the analysts are happier, and they need fewer people to do that job role, and the analysts can focus more on doing their job as opposed to just blindly clicking on things and looking at it without any context. So this was the inspiration behind me developing some of the problems that I talked about before. Oh, by providing context, can we ingest all of this data, use natural language processing, and provide that context to them? Is that helpful? So that is how we translate a business problem to a technical problem. Data quality and data understanding is another important aspect. So typically, when you translate this business problem to a machine learning problem, you want to check if something is feasible or not. Because the earlier you talk about feasibility, the earlier you surface any additional data needs, it is better for the business because they have faith in you that you know what you are doing. And it also leads to lower failure rates towards the end. So in order to do that, we definitely need to explore the data. And by data exploration, I'm not just talking about initial summary statistics, but understand the schema, understand the different values that a particular field can have. So look at all of this and establish a baseline metric. Establishing baselines are super important. And then this totally covers like the data understanding and the data preparation part. And then you actually come to the modeling part, which is actually trying to figure out what would be good options for solving this problem. You don't necessarily go in with, oh, I am going to model this as a supervised problem. There are different ways in which you can think about problems. Sometimes the problem statement completely changes. So initially, there was one question or like one business ask where they said, um, we want you to identify false positives. But later, when we spoke with a lot of product managers, with a lot of users, we realized that they don't like to, you know, say false positive because there's a finality associated with it. Instead, they liked prioritization. So now this became from a classification problem, it became sort of a regression problem. So a lot of these things will change. And there are multiple ways to look at the same problem. So choose your algorithms or modeling technique appropriately. And I cannot stress enough about evaluation. You just recently saw how models can be evaded, how the classifier went from telling something was malicious to completely benign by just adding that one string. So in order to avoid such cases, you have to rigorously test with models, rigorously test multiple models with multiple data streams, in-band data, out-of-band data. By out-of-band data, what I mean is something that the model has not seen before. And also change your inputs intentionally and see how much your output changes when you change the inputs intentionally. So these are all like robustness steps. And then finally, articulating the value of your model is super critical. In the end, your confusion matrix typically, I'm guessing some people here are familiar with the term confusion matrix or a classification report, which is the model's outcome. It says, this was the number that we saw. This is what the model predicted. So help interpret those outcomes to your business. So translate the technical outcome to a business outcome again. And that will truly help drive value. Finally, the deployment aspect. This is currently a very big problem that a lot of companies are facing. All the models are in notebooks. It's very difficult to get the models from the notebooks into actual software development structures and infrastructure. And that is something that I worked on in one of my roles as a machine learning engineer. How do we operationalize machine learning models? It's slightly different from operationalizing regular software because here you have the additional component of data. You not only have to manage the code, but you also have to manage the data. So these are the two things that complicate operationalization of machine learning models further. And I think that this is just a further zoom in view about just the data science process. At this point in time, forgive me, people who are interested in being analysts and data engineers, but I'm just zooming into the data science process. And the data science process, you can iterate over these set of steps, which is you look at what's been done in your domain so far. You look at what kind of data you have, and then develop either new algorithms or use existing algorithms. I'm going to be very honest. Most of the times you will be using existing algorithms. You don't necessarily have to build something from scratch or reinvent the wheel. And then do the result analysis, and then finally do the review. So typically, this is the cycle that you would operate in as a data scientist within your team if you're strictly focused on modeling and algorithm development. So this is a small cycle within this entire modeling piece that you're seeing. Like this is a small cycle that happens. And this is mostly typical of those who work at the intersection of domain plus research. And also, most of the things that are taught to you in your school, in your classes, or in any online courses is typically this phase, which is let's look at what problem we have, let's try to develop an algorithm, let's evaluate the model. So this is the small loop that you're taught in. But then this is just one aspect, and then there are so many other pillars, as you saw previously. This pillar of business understanding to technical understanding mapping, deployment mapping. So these are all those different pillars. All right, I'll pause here and see if we already have any questions. And at this point, I'd like to open up the floor to see how you can start today, right? The whole purpose of this talk is to tell you how you can start today in your role, in your domain as a data professional. What can you do? How can you identify these problems that are worthy of data science? Like, how can you identify these problems where some new technology can actually help benefit you and raise the bar for you? So I'm just going to open the floor here. Please put things in your chat. Anybody in the regulation industry, like legal, do we have any practicing advocates, lawyers? Okay,
Okay,
anybody here
while
in
the
the,
people in the chat came up with their questions, I just
yeah,
quickly wanted to add something from my own side because
yes,
it was a very interesting session so far. But two points that I wanted to highlight for the students as well. That a point that you picked up about the lack of data, right? That is something that a student is completely unaware of right now because being a student, they usually work with the data that is provided to them, right? And I believe something working in this industry as well, that the more specific your problem becomes, the more hard it is to get your data right, because you can get that data about cats versus dogs everywhere, right? That is available because that is general. But the more specific your problem becomes, like you're saying, for your special cases, for it was for malicious intents of those programming strings that you're talking about, right? For some people it might be legal based data. So the more specific the problem becomes, the more hard it is to get the data. And the second part that I would like to add is the deployment phase, right? On a screen or sort of on a curriculum, it looks really small. But when you deep dive into it, deployment is like a whole new other world.
yes.
So these are the two key points that you guys can take away from this. And now, as always, we will like to open the floor for questions or anything that you wanted to discuss.
Yeah, I still have more things coming up, like I'll definitely be talking more about um, the different data flavors or data role flavors, how you can identify these job descriptions. But now I just wanted to ask, let's try to solve a problem for you today. How many folks here are in e-commerce? Like what kind of data you're working on? There could be some folks in the finance industry who are looking to transition. I think for you, there will be some data sets or some interesting problems. Okay, I see some raised hands for the finance industry. So
Mhm.
what are some problems that you're actually facing, right? What is your manager's pain point? I think if I have to hazard a guess, I don't see anything on chat yet, but if I have to hazard a guess, I would say some of the pain points are, can we make a better way for our customers to report any fraudulent activities? I think that would be one kind of a problem. Another kind of problem in the financial space would be, I have a huge list of regulations that I need to comply with. I have a long list of this. How
Mhm.
can I make sure that all my teams are aligned? So I feel like these two problems are a good fit for machine learning. So in case of the fraudulent activity, it's a fairly well solved problem, but there's always scope for improvement. You can definitely look at it as another outlier detection problem. Um, we have a lot of new technologies coming up. So I don't know if you've heard about one-shot learning, but this is very much into the research space. But those kinds of technologies can be helpful. You can start today. You can start right away. You don't have to wait for somebody to give you permission to say that I want to solve this problem. Try to find those problems yourselves and carve out some time, just like as you're doing today. Just take out 1 hour and see what you can do with it, right? I think that's how you can just identify problems. So if you're trying to get all of your teams to comply with regulations, see what can help. We all know nobody reads those end user agreements, nobody reads those privacy agreements. We just click I agree, right? We all just click that. But can it be done better? We've seen Chat GPT, right? We've seen a lot of those things. Um, can we make ChatGPT answer questions saying, hey, is my team compliant? Have we checked off all the marks? Is there something that you can build for your team? So if you're in the finance space, these are some of the problems that you can think about solving. And lastly, I just wanted to share, can you see my notebook?
Yes, the Chrome tab, right? It's visible.
Yes. Yep. Sorry. All right. Cool. I just wanted to show, this typical data science process, which I'm sure all of you have seen. This is precisely the tab that or this is precisely the example that I took. This is like a real world example of some sort of a data that I have. And this was my process of looking at what it means to summarize this data. How do I quickly look at the data, understand the data, and build a model? So this is a typical process that you go through in your classes also, I presume, where you actually go look at the labels, you go look at the different kinds of fields. So mine is extremely security related. This is a dummy data set, so I'm not sharing anything proprietary, but I'm just showing you the methodology in which, I'm going about data cleaning, checking for missing values, looking at the class imbalance. This is something that I pointed out before. Um, Doing a little bit of Python coding, not too much, how to select your features. And also talking about, like, these are all very domain specific. I don't think somebody fresh out of college can come and do this. They'll need to be trained. And the
Yeah,
same
Preeti,
way,
can
if
you?
you're already in a domain, sorry, go ahead.
I'm sorry to interrupt you. Can you
No
zoom in
worries.
a little bit for the?
Oh yeah, absolutely. Yeah, I wasn't sure how it was visible, but yeah, let me just, actually, I can just make this a completely new tab. Is this much better? And then I can,
Yeah,
better?
better. Thanks. Yeah, go ahead.
No
Sorry
worries.
for interrupting you once
No,
again.
no, I'm glad you brought that up. So, just doing a little bit of plotting, understanding, can you actually use machine learning for this problem? So in this case, do we have enough separation? Some of these features don't give you some enough separation. These are all like fairly overlapped. So there's not sufficient separation. So this may not even be a good feature to consider. So these are some of the things that you would typically do as a data scientist. And this is a very initial part. I just wanted to not keep it to just slides and show you that, there are some hands-on dirty work that needs to be done. Model building, as you can see, is a really, really small part. Like, I'm still looking at the features. I'm still, preparing the data here. Model building is just this one part, which is really simple, right? I'm creating a data frame. I'm using H2O, and then I'm just splitting the train test, and then I'm calling a random forest estimator. This is really all that it is. Like, the model building part is fairly straightforward, but there is so much work before and after. And I think I wanted to talk about adding to Yash's point about deployment. So a very interesting thing is we also take in data from the users, and the users sometimes provide different kinds of labels. We actually wanted just 0 and 1 in our labels, meaning something's malicious and something's not, but they also provide -1. So you'll never know what kind of uh, testing environments your models will be subjected to. And all of this comes in the operationalization part of your model. You need to constantly monitor and understand whether your model is doing what it is intended to do. Is it delivering the right kind of value? Is it drifting apart? So these are some concepts that you would have learned, right? Like data skew, data drift, concept skew, concept drift. Um, if not, these are interesting things to go and explore, just adding those things for you here. Finally, coming to the key part, right? Like what everybody's interested in. This is my favorite infographic. You can start off at with the knowledge of your domain. Today, you can start this, and then you can think about how you can apply some problems. So typically, the people who operate at the intersection of the domain and the research, they tend to understand the domain really well, and they tend to go more advanced into their um, research algorithms. Like, can we build a new architecture altogether? Can we build a new algorithm altogether? So these are like researchy data science roles. And then there is the engineering component. This is fairly prevalent. And this is where you do the inputs for the data component, the data science piece, and the outputs for the data science piece. So there is data engineering and machine learning operations or machine learning engineering. A lot of people who understand the domain and who are good with engineering concepts typically tend to take this path. Some folks also like to create high performance um, infrastructure, and those people typically tend to be called research engineers. But most of the time, when I say software engineers in this context, I mean a data engineer and a machine learning engineer. And then over here, we have business and domain intersection. This is also extremely common. Typically, you see them being called as business intelligence, data scientist, or data analyst, or data scientist analytics. So these are some of the job role descriptions that you see. And they operate at the intersection of the domain and the business and inform the business as to what kind of problems we need to solve. So they look into the data, they look into things like KPIs and OKRs and inform the business, this is something that we need to solve. These are the problems that I think is a real problem. So there's a lot of exploration in these kinds of roles. Now, having said that, this is, again, the interactive component here. Look at this job description. I actually created a bunch of I did not create, I curated a bunch of job descriptions. And let's do this, right? Let's do this. The game that we're going to play here is, what do you think is the actual title of this job description? And what do you think was posted by the company that was looking for this, that was hiring for this job? Please put your answers in the chat if you're on YouTube or if you're on Zoom. Great. I see some answers here. So it looks like they are looking to participate, or they need somebody to work with executives and the product. They need to take something from ideation to building reports and doing a lot of A/B testing. So I see analyst, lead BI, data analyst, data researcher. I would say this falls more under the realm of a data analyst, because this is fairly SQL heavy, and they're looking to do a lot of visualizations and reporting and A/B testing. This totally falls under the realm of a data analyst. But the job description that this was posted for was data scientist. So please, when you're looking for a job flavor, when you're looking for a role, don't try to fit all roles, because you cannot really fit all kinds of roles. Make sure that you know what kind of roles you're targeting. So this is one important thing that I would say. And interestingly, they add something in their bonus section. They say they need experience with writing production ETL. They say they need experience for technical leadership and writing performance code in BigQuery. So it looks like they need an analyst plus a data engineer. So, these kinds of information, when you correctly identify the role, you'll be able to better prepare for an interview for such roles. Now, this one here, what role do you think this one is?
Let's see how many get this one right. Okay, we are getting machine learning engineer. Okay, what?
Okay.
What else? I guess they need some time to read it all.
Yeah, no worries. Yeah, absolutely. No worries. So I'll also read along with you, right? They're asking for strong statistical knowledge. They're asking for some leadership skills. They also need people to take this into deployment. They need somebody fluent in SQL. They need somebody to do a little bit of business analyst part, which is like predicting churn and retention of clients. According to me, that totally comes under the business analyst or the business intelligence part. So I'm sorry, everybody, this was a trick question. What they're looking for is a unicorn. And that person does not exist. They need a lot of different things. They need somebody who is here, right here in the middle. And yes, that unicorn will be there. And if you are that unicorn, fantastic. make sure that you ask for a lot of money. But overall, I think when you go into these kinds of roles, go to the interviews with questions, asking them what percentage of each of these things that they need to do. This is one piece of advice that I would give to you. Go with questions as to what percentage of each of these description that you would need to do. And that will help you get an understanding of what your role would actually be and how you would have to prepare. A lot of times this will happen in the first managerial interview, not necessarily in the HR screen, but that is something that I would strongly encourage you to do. And this role, what do you think this role is? It says own end-to-end development of data pipelines, um, architect and deploy high quality code that processes data from a variety of sources. Great. I see a lot of data engineering coming in here, and this is precisely that. So this is data engineering. And I think I saw a question on the chat asking to explain the engineering piece a little more. I would like to say that it is mostly doing these kinds of work. This is core engineering, building out your data pipelines, monitoring the health of your data pipelines. All of this is engineering work. And then lastly, this one. I think this one is easy because it clearly says, as a machine learning ops data scientist, you will have the opportunity to build the next generation of the machine learning platform and infrastructure. As you can see here, the focus here is more on operationalizing the machine learning models, which is why they're asking for experience in CI/CD. For those of you who are not familiar with it, it is continuous integration, continuous development, and with a little bit of understanding of machine learning. But the key aspect here is you need to understand infrastructure, cloud infrastructure such as AWS, GCP, Azure, container technologies, inferencing technologies, REST APIs. I think these are the key aspects here. And you'll have to understand what it is to monitor data skew, what it means to monitor model decay, what it means to register model versioning and building out the operationalization platform. I'm not sure how many of you are familiar with these terms, but I'm just throwing out these terms. You can feel free to, talk to me. So the interview preparation, use your data skills today, right? I'll leave you with this. This is going to be the last few minutes. This is my favorite infographic again. Why? Because anybody who looks at this is going to faint. We can't really learn all of this, right? This is the typical data stack, right? This is everything that is data stack, and you have industry specific data stack, industry specific applications. So for example, I work in this corner, which is the security corner. If you're in advertising, if you're in finance, you will probably using different kind. You'll probably be using different kinds of tools. But regardless of all these applications, I would say there are some core things that you need to know for every role. And that is for the analytics. Like today, one of the questions that I always get asked is, what can I start with today? Today, if you're looking to start this role as a business intelligence analyst or as a data analyst, your job is to generate as many hypotheses as possible, as quickly as possible, and help your business come to a decision. You go from, you have different managers coming and giving their opinions, but then you validate that with data, you develop metrics, you do the analysis, and you provide them a recommended course of action. And how do you start today? This looks like a lot of work, right? But how do you start today? There is a very classic employee database. Load it into your MySQL. If you've never played it before, very easy to do. Start it today. This is one thing that I would say if you want to start as a data analyst today. If you want to start as a data scientist, you saw my collab notebook. It was very easy to start. Everybody, I'm sure, has a Google account. Just go to Google, open your collab notebook. But where is your data? I'll have to be a little partial here. Like getting access to real world data is very difficult, but Google dataset search How many of you here are familiar with Google Dataset Search or have seen it before? So Google Dataset Search has a lot of real world data. Take this, put it in your drive, start exploring. And begin your data science workflow just like what I practiced. And if you really want to up your game, be better at engineering. Try to make your code clean. Try to have an organization or a structure for your data science projects. One of my favorite structures is this, where I divide my data science projects or compartmentalize them into data, code, visualization reports. And if somebody comes and tells me, I really want to put this into production tomorrow, I am in a position to automatically package that and give it to somebody in the development team. So this is one of my favorite structures. This is available in Cookie Cutter. It's called the Cookie Cutter Data Science Template. I will make all of this available in my GitHub repository after this talk, and I will be sharing that link. I'm sure Insaid also has a lot of resources that they can share with you. So start today. And this is my favorite picture about the engineering aspects, which is either doing data engineering and the ML ops, and something that I showed to you before also. The ML code is just one line. It is regression.fit, regression.predict, random forest.fit, random forest.predict. The ML code is really small, but processing your data, massaging the data so that it's ready to become ready for consumption by the ML model, that is a huge part. So I would suggest all of you to go read this blog called The Hidden Tech Debt in ML. This is a very interesting blog post by Google, and this really will help you understand how to monitor your models, how to create those pipelines, both development and deployment pipelines. It gives you an understanding of the engineering ecosystems and how to make an impact with your data science models. And then there is a toy ML pipeline, which I really like a lot. I would suggest you to go take a look at the toy ML pipeline and implement it. If you want to become an engineer, a data engineer, or a machine learning ops engineer, do that today. It's a GitHub repository that has the code. Start implementing it. And lastly, data skills are a means to solve a problem. So use it to solve a problem. And my takeaways for you are play to your strengths. If you are in a domain, do it, understand your domain, try to find that problem, just like how I mentioned, find that problem. Don't make your first jump difficult by applying for high bar roles like research roles that need publications. If you are already a PhD student, sure, apply for that. But if you're not, don't make your life harder than it has to be. Know your strengths, right? Like, what are you really good at? Are you good at engineering? Are you good at analysis? And lastly, or like not lastly, but secondly, don't wait for somebody to give you your job. I did not wait for anybody to give me the data scientist title or a machine learning engineer title. I took data, I cleaned the data myself, and I said, hey, these are some problems that we can solve. So go to your managers and say, have you seen this? We can solve this problem. And this is an approach that I'd like to try. So don't wait for somebody to give you that job, and make a commitment to start today. Like I said, my title says security engineering manager, but based on what I spoke today, I don't think anybody will be telling that I'm a security engineering manager. Most people will be telling that I'm a data scientist or a machine learning engineer. So that's totally fine. It does not matter what you do. And I also get a lot of questions on, oh, should I start with R or Python? Should I learn AWS or GCP? Don't worry about buzzwords and tooling. Learn the underlying concepts. Learn why cloud is good, why cloud infrastructure is good. Learn why distributed systems is good. Learn those underlying concepts. Pick any tool. You will not go wrong by picking any tool instead of being in an analysis paralysis. Pick any tool, and you can always transition into some other tool. And lastly, choose your problems wisely. Don't create unnecessary complexity. Data science is meant to solve problems, but I have seen in many places where data science itself is a problem. Most of the people will come and tell, oh, I need to do this data science project. That itself becomes a problem, but it's supposed to be a tool to solve a problem. And start slow, don't take shortcuts with no code solutions. Try to learn the fundamentals. And then you can do the no code solutions when it makes sense for you and your business. I'll stop that there. And there are only 5 questions in this feedback survey. If you can help fill this out, I know Insaid also runs its own survey. So if you could help us and give me feedback on what you thought this session was like, that would be really helpful. Yash, can you help with the sharing of the link?
Yeah, I just did. So, guys, there is a link in the chat box. This link is for Preeti's feedback form. So, I would request you before we start with the Q&A, can we just fill this form real quick? It will take like 30 seconds of your time, and it will be very helpful for our speaker today.
Thank you so much.
And
And
yes,
yeah,
Neeraj,
while you're
we'll take
filling
that.
the form, while you're filling the form, you can also connect with me, Preeti Ravindra on LinkedIn, Cyber Snacker. Um, and I'd like to say thank you for being a fantastic audience and interacting all over the chat. For a webinar, this turned out to be better than my expectations, honestly. And thank you, Insaid, for giving me this opportunity, because I got an opportunity to engage with folks back in my home country, which is India. So I'm very happy to have received this opportunity as well. Feel free to connect with me on LinkedIn, and then um, the slides will be up on my GitHub repo. So you can just do Cyber Snacker and it'll be on my GitHub repo. And I'll take questions now.
Okay, guys, if you're done filling the form that I just shared for Preeti's, let's just take some questions that you guys have entered in the Q&A section, right? So, first of all, the first question that I'm seeing that is, I guess a lot of people have this particular question in their mind after this talk, and it says, what, as per you, are the reasons of failure in data science roles when you say it's more than 80%? So, yeah,
Yes,
I think we
great
should
question.
clear that up.
Yes, great question. So what I say by that is, or what I mean by that is, in order for a machine learning project to succeed, we need multiple components to come together. It's not just data science. As you saw here, we need the right translation from business to the technology. Choosing the right problem is extremely critical. And a lot of this is done in the business side of things. And when you choose the right kind of technology to solve a problem, it will be successful. But most of the time, since this has been a very nascent space, and since a lot of people are learning how to apply data and get value out of their data, a lot of the times that translation doesn't happen correctly. The second part is operationalization. We see a lot of models in the notebooks, and when something is not operationalized, you typically have a lot of executives asking you questions such as, why is this not operationalized? I spent $2 million. I brought you the fanciest GPUs. I brought you the fanciest CPUs to run your transformer models, but I don't have the end result that I really wanted to get. Why isn't that happening? So it's mostly because of this. And this rate has been improving. So don't get disheartened. This rate has been improving because we are creating a lot of awareness on how to do. And we've been learning from our experience, right? The industry itself is growing. So when cars started, just to draw an analogy, when cars started, it's not like everybody had roads. People were still like driving cars on, like, those horse wagon roads. They did not have insurance. They did not have traffic lights. All of this infrastructure had to be built. And all of this came slowly as people realized the value of it. So it's very similar. You have to realize the value of it.
Great. I guess that answers your question. And before we move on to the rest of the questions, I would also like to send in the insights feedback form. So, guys, do fill that out as well so that we can have a record of your attendance in this session. And on the basis of this, we'll be circulating those certificates as well, right? So, be sure to fill that up. Now, moving on to the next question. And this is also a very frequent question that we get in these speaker sessions that we do, Preeti. How much challenging is it to learn the domain knowledge that always points towards the data science role? Yeah, this type of questions, I guess, come together in an umbrella of about demystifying the domain knowledge.
Yeah. This is an interesting question for me, because for me, the domain knowledge came first and data science came later as a tool. For those of you who are starting in the industry or who are taking data science as a course itself, how do you gain domain knowledge? Talking to the business. There's just one simple answer. It's talking to the business. And what do I mean by that? So if you're a new or a fresh college grad and you are talking and you're trying to understand what your domain is, your first point of contact is your manager, because they will help you and they will point you to the right kind of problem to solve, because those decisions happen at a higher level. So this is one thing. The second aspect is try to attend conferences of your domain. So if you're in security, I attend a lot of security conferences. If you're in finance, I'm sure you have conferences where finance folks are talking. If you're in retail, talk to your sales folks. Try and understand what sells. There are tons of sales conferences that I have seen and have been to as well. So that is how you build domain knowledge. It's truly caring about the problem that you're trying to solve and the bottom line. How am I moving the needle for my company? How am I moving the needle for the business?
I
Does
guess
that help?
that answers your question, Vidhi. The next question is from Neeraj. And he asked, who provides the data for the data science problem to be solved in an enterprise, or who is the one that actually deems the data fit for the problem resolution? I'm asking this because there could be a gap between what is actually needed and what is provisioned.
Great question. Love that question. So what I would say here is it depends on the maturity level of your organization. That is the key answer here. So if you're joining established big tech companies or fairly advanced companies who have a decent maturity level, then this conversation is a conversation that happens between the data scientist, the data engineers, and the management. So there is a particular term called data contracts. You establish what is called as a data contract, where you identify what kind of schema you need to consume for the model, and the data engineers will try and get that from the different kinds of data sources in the format that you would need. So this happens in fairly mature companies. If you're in a startup, high growth startup, you are it. You are the one man person or the one woman person. So you just go, you talk to your folks, or you yourself try to gather all of that data and start working on it and look into some of the interesting new tools out there. So data catalog is something that I would suggest everybody to look at, because a data catalog typically outlines what a data set is, what is the schema, what is the metadata, when something was created, when something was not created. These things will be super helpful. So look into some of these technologies and start proposing this. One thing that I did not mention during my intro was that I think I have intentionally chosen roles where I'm not in extremely mature organizations. I've intentionally chosen roles where I've been the founding member of a lot of those teams, and in different roles. I've been a data scientist, I've been a machine learning engineer, I've been a security specialist, researcher. What that gave me was an opportunity to learn different facets. I've been very lucky to learn that and build everything from scratch. So I know exactly how to build and what different maturity levels look like. So I think I've been fortunate. And if I have to give that as a career advice, please take that as a career advice. Try to be in a place where you can actually make that impact.
Good. I guess that answers that query very well. And another question that we have is, which role assesses the infrastructure required for data problem analysis? So I guess what is the person who creates the infrastructure for a team of data scientists, I guess?
Yes, this is data engineers and machine learning infrastructure engineers. Sometimes the job postings could also be called platform engineering. So you'll see words like machine learning infrastructure, data engineering, and platform engineering.
So I guess that answers your query. Anyone else, if you want any question to be answered, you can ask Preeti right now, because I guess most of the questions that I am seeing right now was coupled to the questions that we already took. So if anyone wants any other queries to be solved, you can say it now. Okay, please brief us about the deployment process, the macro steps that is taken into it. So basically the overall
Okay.
overarching possibilities in there.
Okay. Right. So the macro steps in the deployment. Typically, you engage with the data science team should initiate this conversation with the machine learning operations team. If not, machine learning operations team stay on top of them. The conversation gets started as what is the model itself? How big is it? How to containerize it? So at a very high level, containerization. The second part is the requirements for the model in terms of data consumption and in terms of inference. So inference is when you're doing prediction, and when you've deployed a model, you need to do predictions on from your models. What rate at which you'll get inference requests. These are all scalability problems. So this is the second step, understanding the input data contracts and the inference requirements. Third one is, how do you deploy? What kind of exposures are we providing for this model? I would also recommend reading up on things like shadow deployment, canary deployment. This helps in A/B testing of your models. The fourth step here would be observability. You first need to log what your model is creating so that you can help debug. The data scientists can understand what went wrong, what the prediction vector, what the input vector looked like, what the prediction outcome was, and any other intermediate steps. So a lot of logging needs to happen. And then there needs to be the concept of data drift, model skew, concept drift. These definitely come into picture, but those are a little more advanced. And then versioning. How do you determine when to deprecate one model and put in another model behind the same API endpoint? I think I touched upon this. This is typically canary deployments and shadow deployments.
Hmm.
So at a very high level, these would be the steps.
Yeah, so we have the last three questions for today. I guess we are little overshooting for the time, so we won't keep Preeti here for long. So I'll just take up these last three questions that I'm saying right now. Okay, guys. So the first is from Japjeet Kaur. She's saying, how and from where to start gaining that domain knowledge for a person transitioning from assistant professor role to DS? So I guess people who have not gotten the opportunity to actually work in a business related setting. So how can they work on their domain knowledge?
Great question. I think for this, I'll give an example of somebody I know who works in academia. And interestingly, the kind of projects that they have been involved in is very domain knowledge specific, because I don't know, I'm not completely familiar with how the funding model works in India, but typically academics write grant proposals and they get funding from certain agencies. And they typically get funding from those agencies if they have that domain knowledge already. But to answer your question, let's say you've gotten the funding and you want to just learn about the domain knowledge and you're in academia, how do you do it? Meetups, conferences. Again, it's the same answers. Talk to folks, tell them these are the problems you're facing, and then they will have some insights for you saying, oh, if these are the problems, can you try X, Y, and Z? If something else is a problem, can you try A, B, and C? So this is what I would say would be one way. And the other way is obviously books. So for example, if you want to learn more about trading, I'm sure there are a ton of books that you have to read, but you can get pointers. Instead of reading all the books out there and checking the best review on Amazon, you can ask for pointers from your friends as to what book you can read.
Okay, great. And I've kind of saved the best two questions for the last. So I guess this will be very fun for you to answer as well, Preeti. So the first question is, how was your feeling in your very first data science interview? I'm asking this question because when do we came to know that we are a good fit for that particular role?
Oh, yeah, great question. One of the reasons why I spoke about the interviewing aspects was because I recently went through an interview process because I just like started a new job recently, and I went through a lot of interviews, and I was fortunate to land 5 to 6 offers. And I've also hired about 3 to 4 people in different roles. So I feel like I can speak to both sides of it. My very first failure was for a data scientist role. And I was in this one company for a long time. And I thought, okay, I'll just go interview. I don't know what's going on. I had no idea about what the industry was looking for or where it's heading out. I was in my own tech stack bubble. And then later I realized, oh, there was like so many other things. I think my failure experience was an eye opener in terms of understanding what it is that I needed to learn. So every time I had something that did not go well in my way, I would learn what I actually have to go back and read upon. So most of the times I found that it was the technical skills because I feel like I'm fairly mature, like working in a lot of startup like places. The translation from the business problem to the technical problem is ingrained in you, because if you don't get that right, your business won't survive. So I was fairly okay on a lot of the soft skills aspects, and understanding the core of translating the business to the technical. In terms of understanding the tools, I think that is where I had to ramp up. For example, there were certain places that were looking for very specific tools. Like you had to know AWS. So sometimes don't take those kinds of rejections too personally, because all that means is that that hiring manager has an urgent need for somebody to come and implement that right away, and they don't have the time to ramp somebody up. So look for hiring managers who believe in transferable skills. So when I'm a hiring manager who believes in transferable skills. Okay, you have learned a concept, right? You've learned distributed systems. For me, it does not matter whether you use AWS, GCP, or Azure. I will hire you because you understand that concept. I'll ask you concept-based questions as opposed to tool-based questions. So look for those kinds of hiring managers to get your first break.
Okay, now the last question for today, it is coming from Priyank Agarwal. So, as someone who's included in your daily activities, what is the most challenging task that you have been involved in that was like a nightmare? So, kind of an interesting question from Priyank.
That was the nightmare. The nightmare is always stakeholder management. So, so I think the most difficult part is getting everybody to speak a common language. Even now, I don't know how much of what I said came through, but I always keep trying by using different terms because my audience level varies. One of the things that I say is when you're talking about data science to a lot of customers, in their mind, what they think is Alexa, Siri, and Google Assistant, because that's what they see on a day-to-day basis. But there are a lot of enterprise AI technologies, a lot of machine learning models behind the scenes that you don't even know you're using. So when some people have certain expectations and biases, breaking through that to make your point across is a critical aspect. So that is one thing. The other nightmare that I would say is setting up infrastructure for your data science pipeline and machine learning operationalization pipeline. That was a huge learning curve for me because I had to learn infrastructure as code, such as Terraform, how to bring up all these um, big data lakes in a cloud native in a cloud native way. I wouldn't necessarily say it's a nightmare. When I was doing that, it felt like a nightmare, but in hindsight, I really enjoyed it. It was a very difficult learning curve for somebody who was not extremely comfortable doing a lot of engineering tasks. That was an interesting learning curve for me.
Okay, Preeti, that's it for today, guys. And from behalf of everybody that's joined today, I just wanted to say thank you for joining. No, it was a really delight to see or hear you speak. So thank you once again on behalf of the whole team.
Thank you very much for this opportunity as well. I really enjoyed it.
Okay, guys, if you have filled the form, you can move on. This is where we'll part with Preeti. Bye. Okay, guys, I'll just share the link once again. Do fill out the form, and that's it.